This is another one of my dodgy setups. I've got to taper turn the columns for this beam engine, and it's only cosmetic. Dimensions are not critical in my view anyway. I made this tailstock set over device donkeys years ago for something or other, and you're not supposed to do it this way anyway. I've set the tailstock over really by eye and lightly gripped the end of the column in the chuck. That's the bit you're not supposed to do. You should really use a centre there and a driving dog, but I figured with such a small taper I might get away with it, who knows. So having set the end of the column over, when the tool traverses, it should cut a taper to meet the 3/8 diameter at this end, which it has done. Might want another little cut, but that's the plan. Well, I'm not impressed with the finish, but I think for the moment I'm going to stop. Have a go at another one and see if we can improve. The tool's got a slight tendency to dig in and leave marks, which is not clever. Well, this is the point at which everybody can laugh like drains. That's the first one, and the taper is cut completely in the wrong direction. This is the second one, which actually the taper I think is about right, and I got confused as to which was the top and the bottom of these columns. In fact, there's a parallel section at the bottom, which is this bit, and the taper should, well, as I've shown it, go that way, not twonk as I've done that one. That one's scrap. Okay, only another 3/4 of an hour of my life wasted while I try to figure out the setup. I give up for the day. I'm going indoors. It's freezing out here. So now I think I'm cutting the column the right way round. That's the way I'm cutting the taper in the right direction. I don't know. Don't get old, you get senile. Okay, I now have the basis of 4 tapered columns for this beam engine. They've obviously got to have some of the decoration turned up and sort of fitted on, but that's not a problem. Let's just hope they're right. I think they're pretty much within a couple of thou all the same length, so fingers crossed. Okay, the 4 columns, they're not cleaned up yet and they're not perfectly trimmed to length, but we have the makings, I hope. I've roughed out, well, they're not that rough really, the columns for this beam engine, but I just need to check that the dimension from this point to the capital there is right. And by the drawing, if I've worked it out correctly, the dimension is supposed to be 5.562 inches. So we'll see how we get on, really. I have to buy myself a better vernier. I don't like this one much. So that's 5.58, that's 4 thou 2 short. Not the end of the world, I hope. that one's 5.58, again 4 thou short. That one's 5.564, so technically 2 thou too long and 4 thou longer than the other two I just measured. And that one's 5.561, so 3 thou shorter than the, 3 thou longer than the two shorter ones. I think the real question is whether I God, I hate this vernier. Yeah, I think probably I don't know, I'll take my life in my hands. I'll try and take about 4 thou off this one to bring it more in line with the other three. I think I'll do that. Right, I've carefully touched up the end here. That's now 5.562, which is in theory the right dimension, so might be 4 thou longer than the others, but I'm not going to play about. I think I'll leave it at that before I mess up totally. So I'm going to say the 4 columns are done, ready for erection, and if there's any slight issues on erection, then a little bit of shimming would correct that, I guess. But I think that's the limit of my ability, so I'm stopping. At this point, I've made a slight variation to what I think the drawing says. Basically, I've drilled and tapped the base to this engine 5BA, so the holding down bolts for the cylinder and its plinth are tapped directly into the base, which I think is the way to go. I'm not too sure what the drawing intended. I think they kind of intended for bolts to come up from the bottom somehow and presumably be nutted or tapped on the top, but it seems nuts to me, so that's what I've done. I may yet change these holding down bolts for hex ones. I'll have to make them though, because I haven't got any of the right length. This is just a rough check with things mostly just propped up, just to see where things go. It's unclear to me at this stage why the drawings call for a wooden base as thick as it does. It says 2 3/4 inches, but I don't know why, frankly, it needs to be that thick. So when I'm a bit further on, I might reevaluate that aspect of it. Anyway, for the moment, there's a temporary bit. The wooden base is 2 3/4. Well, actually, I think it's 3 inches thick, so we'll see. I'm an idiot, because of course, having thought about it, the flywheel doesn't sit here. It actually sits outside this metal base, and there's a big slot needs putting in the wooden base, which is why I guess it's so thick, to drop the flywheel down. I think this temporary arrangement is more indicative of where things should be. This is one of the reasons I prop things up, just to figure out what's going where. So easy to start cutting and then discover you've done it all wrong, really. A little bit more about the wooden base for this beam engine. I don't have any wood of the correct depth, which the drawing calls for, of about 2 3/4 or something. And I'm certainly not buying anything, that's not my nature if I don't have to. So what I've done, I've cut down 2 bits of full mica clad, I think it was shelving, that you never throw nothing away, which I kept from something or other, so 2 bits of shelving, and screwed those to a piece of fairly thick decking, sort of stuff you stick in your garden. The rib side's the other side round. Anyway, I've screwed the whole lot together. It'll obviously need cleaning and painting to try and disguise what it is, but the overall depth is now about 3 inches, which should be adequate. And I have to say, with a great deal of fuss, I've a bit of a mess there, but anyway, managed to cut a slot but nearly 2 7/8 I think deep, or something like that, in this wood. Needs tidying a bit because it ain't quite right there, but anyway, a slot in this in the 2 top bits and the bottom bit, which will ultimately accommodate the flywheel. Actually quite a faff really, and it's taken me quite a long time to do. I don't like woodwork, no good at it. Well, I'm no good at anything really, but anyway, so that's going to be the base of it, and ultimately when I've finished it will get a lick of paint to disguise what it was actually made from. The next part I think I'll tackle is to machine this entablature, which goes on top of the columns, so that I can erect the columns and fit that, because I like to see a bit of progress where you start to build bits of the engine. It sort of spurs me on a little bit. This part, I think, surprisingly, needs to be made, certainly its thickness needs to be fairly accurate, because if you mess it up, the length of the columns and the entablature will be all wrong, and I guess would completely mess up things like piston travel and valve travel and whatnot. So there's possibly a little bit more to this than meets the eye, but we'll see how we get on. I've machined the top of the entablature flat as a reference surface, and I put a hole here compatible with the holes I've pre-drilled in the base, and that will form ultimately the locating point where I'll drill through from the base into this entablature, so that all the columns are sort of vertical. If I've done my arithmetic correctly, and of course I may not, so I will need to check, but I think something like 90 thou total needs to be machined off this base in order to come to the 0.685, i.e. 11/16 thickness dimension that is required. A little bit of an aside. Initially I had the fluorescent lights running crosswise across the garage, but I found that in the vicinity of the lathe I had to turn the light around to run parallel, because it gives better light actually on the lathe. Just a silly thing really. Still a bit of a mock-up, but we are getting there, slowly. So I'm running up 4 number 4BA studs, which will attach the entablature to the top of these columns. 1 stud's in, two are done, and I'll just show the setup on the lathe for doing this. It doesn't take many minutes at all. So I use a collet chuck with a piece of steel with the appropriate length. This is my homemade tailstock die attachment, and I've made one of these for every size of BA die that I use, so I've got quite a batch of them really. And the other thing I made a long time ago is a mandrel which just fits in the end of the bore of the lathe spindle, and a homemade handle, which I can't do things one-handed really, but anyway, there you go. So a handle to turn the chuck around, and then all you do, you just run the die holder up to the piece of work, and then frankly just turn the mandrel and count how many turns you want. In this case, for this end, it's going to be 10 turns, and all the studs turn out to have the same length and the same number of turns on them, and it really takes longer to explain than to do. This is the drawer showing my batch of homemade BA British Association thread die holders, and this is the drawer showing my batch of model engineering type thread die holders for running up on the lathe. They don't take long to make, but once you've made them, they're worth their weight in gold. They save so much time, it's not true. And the die holders are just a decent fit on a mandrel which I made for the tailstock. It's a real time saver. I'm going to call it a day for this this phase of the video. The base is machined. That's not screwed down at the moment, but the columns are erected and the top is kind of level, the cylinder's in place. The flywheel's just propped up. Importantly, I've machined up the base, which will be the support for the outer bearing. It's not fixed down, the holes are not located as yet, because until I make the bearing I'm not too sure where that's going to go exactly. Presumably the bearing fits here, but we'll wait and see. So I need to make the outer bearing for the crankshaft, and I call this the inner bearing for the crankshaft. Fit the bearing here, put the crankshaft in, and then just check that everything will line up this side. But that'll be the next stage of operation really. So that's it for part 3 of the 4-column beam engine build. If I haven't already bored you to death or you've nodded off, watch out for part 4 of this build in due course. Probably after Christmas now. Other things are beginning to take precedence. Thanks very much for watching. Cheers.